Hi everyone, my name is Saksham Sharma, and in today's video we are study about subtraction in 1's complement system. Okay, and also in 2's complement system we also study here. So what happened here is, as we already seen how we add 1's complement number, 2's complement number, and all the stuffs we have seen. Now it is we are talk about subtraction. How we subtract. Let's talk about, firstly we talk about addition, how we add, then we can relate how we subtract. Okay, so how we add? When we have to add two numbers in 1's complement form, I am talking about here is all 1's complement form, then simply we add the number, and then when we get our answer, we already know, that's why I'm not talking about all these things addition, we already know. And when we get our answer, we add the carry if carry is generated. If generated, then we add the carry. Okay, I write in short here. Now what happens in subtraction? What I have to do in subtraction here is a minus b. What I have to do, whenever I am talking about, whenever you see minus sign in this, whenever you see minus sign with any variable or any number, when you find minus sign, you just have to take 1's complement of that number. You have to take 1's complement of that number. Okay, why? The intuition has already been given in previous lectures. That's why. Okay, now we add this here, and if the carry is generated, we simply add the carry. Carry is generated, we simply add the carry. That's how we solve this question. Okay, I also talk about second 2's complement system also here is like subtraction in 2's complement system. How we do? We just see this number also in 2's complement form. So what we have to do, just we have to simply to find the 2's complement of b. Whenever we find minus negative number with any variable, we find the 2's complement of that number and we add with another number, and if the carry is generated, we discard the carry in 2's complement form. Okay, just remember this. In 2's complement form, we just find the 2's complement here or discard the carry. In 1's complement form, we with the variable the variable with the minus sign, we just take a 1's complement, and if the carry is generated in addition, we add the carry. Simple stuff. Okay, now we will add now we will subtract this and solve all the types of things that came in our mind. Okay, so now here also I want to write like both the input and the output is present in 1's complement form. Both the input and the output present in 1's complement form. Both the input and both the output present in 1's complement form. Now what would this mean is, like, let's take an example. We take different example like 4 minus 5. Let's suppose we take this and our answer has to come is minus 1. Okay, minus 1 we want to get. But before solving any question, just find the range. Please find the range first. I have already made a video how to find the range intuitively. So I just write, first of all, I just write directly formula here, but you have to know how this formula came. Okay, 1 to positive 2 power n minus 1. Okay, so I have to represent this number in in 4 bits. I want to represent this number in 4, like 1 2 4 8 1 2 3 4. I can write 4 also here, and minus 5 also we can represent in this. So I want to write 4. So what is the range I get? Minus 7 to plus 7. I get this range. Okay, I got this range. But when we are when this scenario came minus 4 minus 5, then we add these two numbers and sign is minus 9. Then this cannot be created. This created overflow and give us wrong answer. That's why I have to take 1 bit large 5-bit number. 5-bit number, when I take 5, then this range become 15 to 15, positive 15. Then this number can also be taken. Okay, so I have to represent this number in 5 bits. Why? Because of the range. If I don't take this, then this give error in minus 4 minus 5 solving this. Okay, it does not give this error in 4 bits in this, but it give error in this. So I take a generalized 5 bits here for all the caution, like that. Okay, so let's solve. So what we have to do? First of all, we have to write 4. 4, how we write 4? 0, 1, oh, I have to write 5 bits. 1, 2, 4, 8, 16. I have to write in 5 bits. How we write 4? 0, 0, 1, 0, 0. Okay, and how I write -5? Like how to write -5 we already know, but I just tell you that for writing -5, what do you have to do? First of all, write how you write +5. +5, how you write +5? Okay, how you write +5? So this is a simple thing. How you write +5? I write here 1, 2, 4, 8, 16. How you write +5 here? 0, 0, 1, 0, 1. This is how you write +5. From here you can take how I am converting, and you have to take a 1's complement of this. 1's complement. Why are you taking a 1's complement? As we are talking about 1's complement subtraction, we are subtracting 1's complement numbers. So I have to convert this -5 in 1's complement form, na? Because both input is in 1's complement, output is also in 1's complement. So I have to convert this I have to represent this -5 in 1's complement. So what is the procedure? First of all, how you represent +5? This in binary, this, and we take 1's complement, and this is our -5. This is our -5. This number represent -5. This number represent -5. So I write here. Okay, I write more intuitively. Like here is whenever you see negative sign, you have to write 1's complement of 5. Okay, like this. Like here is also written that +5, 1's complement is this. So I have to write here is also 0, 0, 1, 0, 0 plus 1, 1, 0, 1, 0. Or you can write intuitively also. This is the method 1. You can write like this in upcoming all the questions we have given, or you can write directly also. How you can write directly? Like for this minus sign, 1 bit is there. First bit is represent the sign minus for -1. How you write 5? How you write 5 in 4 bits? How you write 5 in 4 bits? In 4 bits, how you write 5? 1, 1. Okay, 0, 0. You have to just take the 1's complement of this number. 1, 0, 1, 0, like that. So this is our answer. This is our 1's complement we do. Okay, so 1, 0, 1, 0, 1, 0, 1, 0. This is also you can see. Okay, so what you have to do, what we have to do in this method, we just simply write negative sign, we represent negative sign bit, and we take a 1's complement of 5. Well, we take a 1's complement of 5, and then we write this. Or you can also think like that. How you can make one positive one here? How you may? We only focus on these bit. We are not talk about a sign bit. Okay, how you write 5 here? 1, 2, 4, 1, 2, 4. Here I have to take 1, 1, but this is a 1's complement form, so this must be 0 and all the other one should be 1. You can think like that also. Okay, so this is the procedure. Method 2 is directly write this, or method 2 in method 2 also you can think like this is for sign bit, and the remaining bit how you represent 5, and you have to take a 1's complement of that. Okay, like that. Just simply what we do, add 0, 1, 1, 1, 1. No carry is generated, so no problem. If carry is generated, we add the carry, but if no carry is generated, so there is nothing serious. So this number is also present in 1's complement. This number is also is in 1's complement form. So what we have to do is we have to convert this number in numeric for checking our answer. In decimal number we have to convert this to check our answer is correct or not. So this number we have computed in 1's complement form, as output is also in 1's complement. So first bit represent sign, and we have to take a 1's complement of 1, 1, 1, 0. So minus 0, 0, 0, 1. So answer is -1, as you can see. Okay, -1 is our answer, and this is our match with our answer. So that's how we solve these questions. Okay, so like that. I can write here is also like +5 minus. Okay, like this we have done. Okay, we solve different types. Like now we solve this. Next we solve -4 +5. Then we solve -4 -5. Okay, so this is also can be written like minus like this. Also can be written like this, give our plus. Okay, this gives us plus, so that's why I'm not writing this. Okay, let's solve all the types. So now we will solve fastly, like minus 4 plus 5, minus 4 plus 5. How you solve? What is our answer? Answer we get is 1. Answer we get is 1. Let's solve fastly. Okay, I write here 1, 2, 4, 8, 16. Okay, just write fastly. 16, 8, 4, 2, 1. Okay, just write fastly. How you represent minus? For minus, first one is our sign bit. So first one is our sign bit 1, and how you represent 4? You have to write 1 here for 4. So we take a 1's complement of that. So 0, 1, 1, 1. Remember, represent the sign first, and how you represent 4? You have to take 1 here, but there is a 1's complement system. 1's complement is 0, 0, 0. Sorry, 0, 1, 1, this one. Okay. How you represent positive 5? Positive 5 simply converted into decimal. Nothing serious here is. In positive number, nothing serious. Now add 0, 0, 0, 0, 0, 1. Carry is generated. We basically add the carry. Carry, this is our carry. We just simply add the carry, and we got our answer is 1. You can see our answer is positive 1. Our answer is positive 1, and this is our correct answer. Okay. Now solve another question on this. Okay. Now solve next question here. Let's solve another question here. Okay. What type is remaining? Minus 4, minus 5, and answer we get is minus 9. For this number, we take 5 bits in here. Okay, so let's solve this number. How you represent minus 4? I write here 16, 8, 4, 2, 1. How you represent minus? 1 bit is, first bit is for sign. Minus 4, how you represent? You have to write 0 here and 1, 1, 1. Okay, for minus 5. 1, 1, 1. Okay, you know that how we are solving. Minus for 5, how you represent 5? You have to take 1, 1 here and here is 0, but you have to take 1's complement of that. So you can analyze that. For if you want, this is how you can create 5 for 4 and plus 1. So you have to write 0, 0 here, as it is a 1's complement. You can analyze this by your own and solve. Or you have a chance that minus 4, how you represent minus 4? How you represent plus 4 first of all? How you represent first 4 in 5 bits? 0, 0, 1, 0, 0, and take a 1's complement of that, 1, 1, 0, 1, 1. So that's how you can also do that. This is just a procedure or you can say a rote learning of something, but you can intuitively solve this also. Like, yes, we are represent first bit is for sign, and the 4 bit how you present in 1's complement. So that's how you can also think. And when you solve this, what do you get? I just rub this, as you know, get confused. 1, 0, 1, 0, 0, 1. So it's not 0, it's 1. Okay. Addition, we just add this here bit, and we get 0, 1, 1, 0, 1. Okay, so this represent our negative sign, and we take a 1's complement of 0, 1, 1, 0. Okay, so 1's complement of this is minus 1, 0, 0, 1, so 1, 2, 4, 8. Okay, sorry, 1, 2, 4, 8, 8. 8 plus 1, 9. Okay, this is our 8 position of 1. 9. We get our answer 9. Okay, that's how we solve this question. For remaining one type, that is a plus 4 and plus 5. So basically you are adding here, so basically you have to convert this into binary and just add, simply just, that's how we solve. That's why I add, just add, nothing serious here is. Okay, so this is basically like a addition, but we are going to solve a subtraction here, so I'm not solving this, as this is also solved in previous lectures. So now we will see the same scenario in 2's complement. Now we'll see the same scenario in 2's complement. What basically happened in 2's complement? Just simple same thing. A minus B. What happened is take 2's complement of this and add 2's complement and just add 2's complement of B and just add. If carry is generated, discard carry. Discard carry. Okay, discard carry, just a simple intuitive thing here, like that we have also do in a previous examples. Okay, so yeah, so what is, first of all, when we talk about 2's complement, how many bits we take to solve this, how many bits we take. So here range is 2 power n minus 1 to 2 power n minus 1. Okay, n power n minus 1 minus 1. Okay, so this is our 2's complement range. You can also find this intuitively, which video is already uploaded if you watch that this. Okay, so what is the range? If we talk about, we are taking some another numbers, a number like 5, 7. We take these two numbers. So 7. If we add 7, as overflow can come in both, sign is same. So we are going to do the subtraction here is, so subtraction 7, 8, 9, 10, 11, 12 minus 12. So how we can represent minus 12? So if we take a 4-bit number, can we represent minus 12? For 4-bit number is 8 minus 8 to range, but we have to take a 12 here, so we cannot take 4-bit, we take 5-bit. To 2 power 5 means 4, 16 minus, so this is basically a good thing. So we have to take a 5-bit to represent these numbers. 5 bits we take, as this is come in our range, so we take 5 bits. So 5 plus minus 7 in 2's complement we have to solve. So what the answer must be? Minus 2. Okay, let's solve this. First of all, how you represent 5? I write this 16, 8, 4, 2, 1. How you write 5? Positive number just basically converted into binary. Just in negative sign, this is also a negative. For negative, first bit represent sign, and that's how you represent 7 in 2's complement form. Represent 7 in your mind and do the 2's complement. Represent 7 in your mind and do the 2's complement. Like I have do, firstly I do in basic form that most of the student can do. 16, 8, oh, I can directly write this also. 0, 0, 1, 1, 1, and we have to take a 2's complement of this. 2's complement we have to take. So what we take is 1, 0, 0, 1, 1. Okay, that's how we take a 2's complement of this. So we write 1, 1, 0, 0, 1. Okay, so this is the basic procedure which we have to follow. And if you can do in a mind, like this represent in a mind, first bit represent minus, then how you represent 7, or how you represent 7, you can take think in your mind like 1, 1, 1 represents 7, and here is bit is 4 bits is there for this representing number, 4 bits are there. So you take a 2's complement like this, then you can write this here. Okay, like you can think in your mind also. Now just add, simply add this 0, 1, 1, 1, 1. No carry is generated. If carry is generated, then we discard the carry, simple. Okay, this number is also present in 2's complement form, like both input and output present in 2's complement form. So we have to convert this binary into decimal. So we have to analyze this according to the 2's complement. First bit represent negative, and 2's complement of 1, 1, 1, 0. So what we have to do, 1, 2's complement of this is 0, 1, 0, 0. So minus 2 is this our answer. That's how we solve this question. That's a very easy question. You can solve any combinations by your own also. So let's solve this. what the answer came, minus minus plus 7, we already seen minus 12. Okay, how you represent minus 5 in 2's complement, okay, 16, 8, 4, 2, 1. How you represent minus 5? For minus 5, how you represent 1 1 0, sorry, 1 1 0 1. That's how you represent minus 5. Okay, 1 1 0 1 1. How you represent minus 7? For first sign bits 1, for 7 what you do, this 1 1 1, so 1 0 0 1, or you can also see from here also 1 1 0 0 1. Okay, just add this 1, sorry, 0 0 0 1 0 1 1. Carry is generated, discard carry. So this is our answer. So first bit represent sign and 2's complement of 0 1 0 0. So minus answer is 0 0 1 1 of this. Convert this into binary, sorry, decimal. Convert this into decimal, you get 1 2 4 8, 8 plus 4 12, minus 12, your answer you get. Okay, you can solve any other combinations also by your own also, like what remains, this remains, answer is 2, positive 2. Simply you can just write how you represent minus 5, 1, this is 8, 4, 2, 1. That's how you represent minus 5. And how you represent 7, 1 1 1. That's how you represent 7, 1 0 0 0 0 1. Carry generated, discard this carry. Oh, something wrong. 16 8 4 2 1. Negative sign, 1 minus 5, negative sign. This 2's complement I have to take, so 1 1 1 0 1. Okay, here is also 1 should be there. Okay, so this is our correct. I just not write this. 1 is there. 1 plus 1 10, 1 plus 1 10. Okay, 11 10 10. This is discarded, and how you write this, 2, positive 2 answer, positive 2 we get our answer. So that's how we solve this. We've talked about positive thing. You can also see there is no thing of 2's complement subtraction, and if we add 2 positive numbers, this is the addition part. So we are also not doing this like plus 5 plus 7. Why we are plus here? If we talk about subtraction, we already completed that addition part. So I hope you understand all the things which we have which we had do there. So I just want to summarize in few words. Like in 1's complement, how you subtract in 1's complement, you just have to see which variable have minus, which number is of minus. If there is a number of minus 5, how you represent in 1's complement form, represent this 1's complement form and add with another number, you get the answer. If the carry is generated, add the carry in 1's complement form, add the carry. Okay, in 1's complement. In 2's complement, what we have to do, you have to just see the minus sign. Minus sign is there with any number, you have to convert that number into 2's complement form, add with another number, and the number you get. If the carry is generated, discard the carry. If we are talking about 2's complement, discard the carry and compute the answer accordingly. So that's all for this video. Thank you for watching this video.